Hello and welcome to Decreations Resources. We are talking about concepts from mathematics, especially real analysis. Let's start by talking about the real number line. In our earlier episode, we have spoken about different sets of numbers or different classes of numbers, and we realized that all of them come under the umbrella of real numbers. So natural numbers, which are a subset of whole numbers, which are a subset of integers, which are a subset of rational numbers, all belong to real numbers. Even all the irrational numbers belong to real numbers. Then the question would arise that what would be the geometric equivalent of this? So the real number line is in fact talking about the geometric equivalent. So real numbers can be represented geometrically by points on a line, and this particular line can be constructed such that you can arbitrarily select a point on a straight line, and that point will represent the number 0, or it is also called as origin. Now if the line is horizontal, then the point at convenient distance to the right of the origin is chosen to represent the number 1. This is going to determine the scale. So whatever is the distance between 0 and 1, you know that much distance will be used every time you are increasing the number or decreasing the number by 1. Now each positive real number lies at an appropriate distance to the right of the origin, and each negative real number lies at an appropriate distance to the left of the origin. And then a one-to-one correspondence is set up between the set of all real numbers and the set of points on the number line. That's exactly one point on the line is associated with one real number, etc. Conversely, exactly one real number is associated with each point on the line. The real number that is associated with a point on the real number line is called the coordinate of that point. So here the idea that every real number can be represented by a point on the line, you can see that this representation is also unique in the sense that no two points will be representing one single real number, or no two real numbers will be depicted by a point. So it's a unique correspondence. Now here you can see the origin denoted by 0 at the center. On the right side all the positive numbers are there. You can also, that's why I call it as positive direction. On the left side all the negative numbers are there. So basically we are talking about integers so far. So left side you can call it as negative direction. Then what about fractions? What about rational numbers? So if you consider a rational number minus 1.5, which is basically represented as minus 3 by 2, it can be, of course, the minus sign indicates that it has to be on the left side of the origin, and 3 by 2 indicates the distance. So we have already affixed a distance for 1, and this is 1.5. So there is an additional half of the distance that is to be added, and that is how minus 3 by 2 can be plotted on the line. Similarly, if the number is 0.2 or 2 by 10, even that we know the scale for 1, so accordingly just divide it by 5 and then you get the position for 0.2. What about an irrational number? So let us consider root 2. Root 2 is an irrational number. We've already seen it, how its value 1.4, it just goes on. Now the value is more than 1.4, so the point of course is going to lie between 1 and 2, and this is going to be the approximate position for root 2. Now similarly, if I say root 3, where will you plot it? Well, the value goes as 1.732, etc., etc. Again it will be between 1 and 2, but on the right side of root 2. If you want to plot the irrational number pi, where will you plot it? Well, the value is 3.14 and other numbers, so it has to lie between 3 and 4. So you can understand that every natural number, every integer, whole number of course because 0 is included, every rational number, every irrational number can be represented as a point on the real number line. So it's a very compact, you can say, correspondence, or when you just visualize this line, all the concepts are incorporated in this. So rather than describing so much, if you just see this figure, it's going to make the concepts clear. So this is about the real number line, and in the next episode we'll be talking about intervals. Thank you.